Here we are at example 3 from our 8.5 set of notes. We're asked to simplify the following expression. We notice this rational expression is being subtracted by this rational expression. And usually we start off by finding what is the least common denominator. And unfortunately here, we notice that there's nothing that they share in common. So as a result, the entire bottom piece is just going to be 2x minus 5 times x plus 1. And so in order to get that, we would have to multiply this one by that 2x minus 5 on the bottom as well as the top. The one on the left, though, we would have to multiply this by x plus 1 to get that least common denominator that we're hoping for. And then also x plus 1 on the top. Doing our next step, we're going to go ahead and distribute that 4x into both items. So when we do that, we end up with 4x squared plus 4x divided by that x plus 1 divided times 2x minus 5. On the right side, I'm going to go ahead and just drop down the minus symbol. The 2 is only being applied to both items, in which case we would end up then with 4x minus 10 on top divided by our x plus 1 times 2x minus 5. Now that we've simplified the tops as much as possible, it's really important to note that we are taking this rational expression and subtracting this rational expression. If we put parentheses around these, we haven't changed anything. Next, what we should hopefully notice is that when we subtract this rational expression minus this rational expression, we have to distribute that negative into both pieces. That is a very, very, very common piece that I don't see that negative applied to this second piece, that negative 10. So just be careful of that common pitfall. There's nothing that can be combined with the 4x squared, so we have 4x squared in front. We have 4x minus 4x, well, those are gone. And then we have really nothing, or you could write plus 0 if you really want. So 0 minus negative 10 comes out to be positive 10. On the bottom, we have our x plus 1 times 2x minus 5. Next, what we would typically try and do is factor out the top. When we do that, we end up with being able to pull a 2 out of the top, leaving us then with 2x squared plus 5. Unfortunately, nothing can cancel out, but we at least check to see if potentially something could. And as a result, this then would be our final simplified version of example 3 from our 8.5 set of notes.